Hello CHM 1010 group. This is chapter 2 electron configuration writing. Okay, so I'm going to record a video with writing how to write the electron configuration including the theory. So let's start electron configuration from the electronic structure of the atom. Now you all know what is the electronic structure of the atoms, how the atoms and subatomic particles are arranged inside the atom. You have idea about a nucleus of the atom. Atom you can consider as a spherical shape, and then in the nucleus neutrons and protons are located, and surrounding the nucleus electrons are confined to energy bands. The electrons are located and moving on these energy bands. These energy bands we called principal energy levels. The name is principal energy levels. Another name is shells. Shells. The symbol for the shell is lowercase n. This shell can be 1, 2, 3, any whole positive numbers, positive integer whole numbers. N is equal 1 is the lowest possible level. That is the energy level closer to the nucleus. N is equal 1, and then N is equal 2, and then N is equal 3, and so on. And in principal energy level, so the shells, the lowest possible energy in the energy level closer to the nucleus, and then next highest energy, and then next highest energy, and so on. Energy is increases when the shells are moving away from the nucleus. Right, this is about shells, and shells can vary 1, 2, 3, and so on. Now the second topic is, let's divide shells into subshells. Shells we divide into subshells. Subshells. There are 4 names for subshells: S subshell, P subshell, D subshell, and F subshell. Right? S, P, T, F. These are lowercase letters. Now, how many subshells in each shell is equal to n? Example, n is equal 1 containing 1 subshell, that is only S. N is equal 2 containing 2 subshells, that is S subshell and P subshell. N is equal 3 containing 3 subshells, S, P, and D. N is equal 4 containing 4 types of subshells, S, P, D, F. Right? Those are the subshells. How many subshells in each n value is equal to the n value? 1 containing 1 shell, 2 containing 2 shells, 3 containing 3 shells, 4 containing 4 shells. Those are subshells. And one thing I forget to tell you, how many electrons occupied in the shells is given by a formula 2n squared. 2n squared. So example, n is equal 1 level, how many electrons can occupy the maximum? 2, 1 squared is equal 2. And n is equal to the second energy level, how many electrons maximum occupied? 2 times 2 squared. 8 electrons can occupied in n is equal 2 level. N is equal 3 level. 2 times 3 squared, 18. And then n is equal 4 level. 2 times 4 squared, 32. So n is equal 4th level, there are 32 electrons can occupied. Right? This is how many electrons can occupied in each energy level or each shell. And these are subshells. How many subshells in each shell is equal to the n number. Okay. First we learn about the shells, and then we divide shells into subshells. Now let's further divide subshells into orbitals. Okay. What are the orbitals? Orbitals are the regions inside these subshells where the maximum probability of finding an electron. They are regions In that region, we can find the maximum probability of the electrons. These are orbitals. They have the same names: s orbital, p orbital, d orbitals, and f orbital. Now let's see what are their shapes and then how many electrons inside these orbitals. S orbital normally spherical in shape, like a sphere. S orbitals. So S orbital size, if we consider in n is equal 1 level S orbital, we called 1s. In n is equal 2 levels S orbital, we call 2s. n is equal 3 level S orbital, we call 3s. And n is equal 4 level S orbital, we call 4s. This S belongs to 4. This S belongs to 3, and this S belongs to 2, and so on. And what are the sizes? 1s is smaller than 2s. And 3s is bigger than 2s, 4s is even bigger than 3s. So size of these s orbitals are getting increased when the n with n numbers 1, 2, 3, 4, 5, 6, even bigger. Smaller size in smallest s orbital in 1 level, n is equal 1 level. That is about s. Let's talk about p. P orbitals are dumbbell shape, and also p orbitals does not exist as a single like one sphere. They exist as sets of 3. So we can draw 3 boxes like this. So this one box we can consider as one p orbital, another p orbital, another p orbital. So they always exist as a degenerate. Degenerate means equal energy 3 orbitals. P orbital shape is this one orbital. Actual shape is dumbbell shape, like a dumbbell, right? This dumbbell shape p orbitals, there are 3. So these shapes lie along the Cartesian axis x, y, z. So if it is along the z axis, then we call it is pc. If it is along the x axis, then we call it is px. If it is along the y-axis, we called it is py. So this is how we name p orbitals: px, py, pc. These are subscript x, y, z. Now we talk about sp orbitals. Let's talk about d orbitals. D orbitals, like p orbitals, they exist as 5 set of 5. So let's draw 5 boxes. So these d orbitals exist as 5. So we can name these d orbitals simply d1 to d5, d1, 2, 3, 4, 5, or another names having these d orbitals: dxy, dxz, xz, dyz, dz squared, and dx squared minus y squared. Those are the names for these orbitals. Don't worry about these names, just try to remember d1 to d5, there are 5 d orbitals. And let's consider f orbital, that is our fourth one. F orbitals, p orbitals exist as 3, d orbitals have 5 set of 5, f orbitals set of 7. Right? So I will draw here, there are 7 boxes. 4, 5, 6, 7. F orbitals exist as 7. So we discussed s orbitals are spherical in shape, p orbitals are dumbbell in shape. However, you don't need about the d orbital shape and f orbital shape since they are complicated. So at this level, just try to memorize, try to understand there are 4 different types of orbitals. S is spherical shape, p is dumbbell shape. There are 3 p orbitals, set of 3, px, py, pc. D orbitals, there are 5. F orbitals, there are 7. That is about orbitals. Now let's see how electrons are occupied inside the orbitals. The next page. S orbital. So I will draw here boxes to represent the orbitals for your comfortability. So So let's try s orbital exists as a one box. So how we can represent electrons? Electrons we have to draw like a small arrows, one up arrow, one down arrow, right? In each box, each orbital, the maximum number of electrons we can put it in is 2. So how we can put 2 electrons here? One up arrow, one down arrow. This is one electron, this is another electron. 2 is the maximum. And p orbitals. P orbitals always exist as a set of 3 in one box, that is one orbital. There are 2 electrons, another orbital there are 2 electrons, and third one we can put 2 electrons, total 6. This is total 2. And d orbitals always have 5 set. They exist as set of 5. And each box there are 2 electrons. Then total is 10. And f orbitals it exists as 7, 4, 5, 6, 7. Each box again 2 electrons. Then total is 14. Right. So each set of orbitals and how many electrons they can occupy. So maximum number of electrons, maximum number of electrons occupied by each orbital is 2. Right? Maximum number you can put it here 2, no more than 2 occupied in each orbital. That is about orbitals.